Okay. We're going to go through factoring using a method called decomposition and another one that I don't have an official name for. We'll just call it fearless factoring. I've set them up side by side. At this point, we're going to assume you know what the standard form of a quadratic is. Just for a quick reference, here's your A, your B value, and your C value. Just because it's going to be important for parts of the decomposition. We'll do decomposition on the left-hand side first, and then I'll show you the fearless factoring stuff on the right. All the steps for decomposition, one of the very first things you need is a pair of factors that equal to whatever A times C is. And in this case, that's 6 times positive 10. So two numbers that multiply to 60. Those same two values need to add up to the B value. And the B value in this case happens to be negative 11. Negative 11. Oh, okay. I got a pair here. Negative 5 and negative 6 give us positive 60 when multiplied, and negative 5 plus negative 6 give us negative 11. So in decomposition now...
Wait, what? Negative 5 times negative 6 is...
Oh, that's 30. 6. What am I talking about? Thank you. You're right. It's good. Oh, shoot. That's the wrong button. Let's erase that. That's not right. Let's give me another factor here. Keep thinking with me here. I was thinking 30. 12 and 5. No. Maybe we better write them out. Let's start writing them out. 60 and 1. 2 and 30. 3 and 10. 2 and 30. 3 and 10. 4 goes in
3 and
times?
10.
How about...
Why is 3 and 10 1?
Oh, 6 and 10.
This is 6 and 10?
Yeah. 3 and 20. Thank you. 4 and 15 give us the 11 when it's a difference, but because it's positive 60, I can't have a negative value. Yeah, so that one's like a bit misleading. 3, I don't know that. 1, 2, 3, 4, 5, and 12. I'm going to erase what we have below here to give us some room. 5 and 12. And this is one of the downfalls of decomposition, is if you got a number like this with so many factors, there can be a lot to walk through. 5, 6 and 10. 7, 8, no, 9, no, and back to 10. Did we write these factors?
It's not possible.
Oh, this is a good question. Maybe this one isn't one of the ones that is possible. What we can do, so, just because it doesn't factor easy doesn't mean it's not possible. 6, negative 11, and 10. 6x squared, negative 11x plus 10. Oh, this one is not possible. Look at that. So, what happened here is this has a vertex that is above the x-axis and opens upwards, which means it has no roots. And to factor it or put it in a factor form, it needs to have x-intercepts or roots. If I say x, let's see if I can get a good one here. Negative 11x minus 10. Does that give us good values? Nah. This one also becomes pretty difficult to factor because it doesn't give us whole numbers. Now, it doesn't mean it's not factorable. It is factorable. It's just they're not natural numbers, which is what we're used to factoring with. What can we change in this question? Oh, I know what I can do. My original thoughts, which were wrong, but might work out nicely here.
Ooh. That doesn't work.
No.
Or it does.
Positive 30, negative 11. Did I write this one wrong the last time I did it?
Minus 30x works.
Minus 30x?
I think so. That works. Yeah, minus 30x plus 10.
That gives us some nice values. Yeah, it works, but... So what I'm attempting to do right now is because... And which is a good... this is a good talk about infinite. There are an infinite number of numbers between any two natural numbers. Between 0 and 1, I could just make so many different values. We're looking for ones that are produce natural values, which means they're somewhat easy to work with. Why didn't... No, this one was factorable. Yes, this one was factorable. All right, I'm going to change it. That's because those factors didn't work out. I'm going to change the values here just so we can do a little with this question. Okay, so we figured out that one wasn't factorable. But if I change this to 3, that puts me back at my original mistake. And in this case, I guess I better erase all these factors because they'll no longer pertain to this question. But what's nice about this is if we do it 30 again, if we say 30, those 2 original ones I went with, -5 and -6, they work. Okay, so this is now a factorable question by just changing the a value. And we've already gotten a hint. I'll turn the other 2 off here. I'll give you a hint that, one of them is going to be a nice number. One's not going to be as nice, which means we're going to get kind of a fractional value, which is fine. We're going to talk about that after. So these check out. So if we go into our decomposition, we write our a value, 3x squared. We decompose -11x to -6x and -5x plus 10. These are now sets of pairs. So the first 2 terms, we look for a common factor. A common factor happens to be 3x. Comes out of both of these. Okay. So when we go to our next line, we're going to write 3x as the common factor here. This, when we divide it, ends up being x. This ends up being -2. When we factor the last 2 terms, so I know I'm going through this a bit quickly. At this point, I'm hoping you're okay with this because I want to show that second style. I'm going to common factor out -5. And the reason I'm doing that is because I'm looking at this original one and I know the process. I know that I need the brackets to match. If I don't divide by negative, I'm going to end up with a -x, which means these brackets don't match. So I'm common factoring out the negative. It's sometimes tough to tell, should I factor the negative out or the positive? If you already have a bracket here, you're trying to match them. So because my x is going to be positive, I want to make sure this, when divided, becomes positive. So I take out -5. And when we take out that -5, -5 divide -5 gives you positive x, okay? And 10 divide -5 gives us that -2. Perfect. We checked out. We got 2 sets of brackets that are the same. We know when we write this now, we can just say x minus 2. And these are the 2 leftovers. They can be in the other bracket, 3x minus 5, okay? Another style of factoring, instead of doing this decomposition, is to actually write these factors out. This is where we're talking about the one we've coined, fealess factoring. 3 is a prime number, so I'm going to write them vertically below, 1 and 3. Now, if the last number has a lot of factors, it can be tough. In this case, there's not too many. It's just 10 and 1 and 2 and 5. I'm going to write x's here because they help a little bit. What we're going to do is we're going to be multiplying columns. I think I have a line drawer. Yes, I do. So I want to think of this as a pair. And they have to be written as pairs. We can't just mix and match everything. These columns have to essentially, they're telling us, hey, these are the 2 pairs of numbers you have to use. And when we multiply them, these 2 values have to add up to the b value. So it's similar to that idea, kind of like that a and c stuff, but we've written it a little differently. And hopefully we didn't have to go through this big decomposition process. We can do a little bit of testing. So in this test, I'll write them in blue. I'm going to do 1x times 1 and 3x times 10. That gives me 1x and 30x. Even if I put a negative in there, that's not really going to work. So I'm going to take those away. That didn't pan out. Not only can I go directly across, but I can crisscross too. This would give me 3x and this would give me 10x. Again, that didn't work. So think of it like I've exhausted my options for the first column. So this first column, I know it's not that. I'm only left with 1, so it's definitely going to be some iteration of that one. Let's say 1 times 2, that gives us 2x. And 3 times 5, that gives us 15x. Doesn't quite pan out, so we can't go across. Our last one might be 1 times 5 and 3 times 2. 3x times 2 gives us 6x. And 1x times 5 gives us 5x. Hey, this is going to work out, except that they both need to be negative. Okay? I need them both to be negative, which means I'm going to put the last term here, because these are factors, -2 and -5. Okay? So I kind of filled them in after. Now this checks out. What I can do at this point is I can jump right into my factored form. I'm going to set up my 2 sets of brackets. This first column here This is going to be the first term in one of the brackets, so 1x or just x. And this is going to be the first term in the other bracket. Okay, so those are our first terms. Make that an x. These are going to be the second terms. I just have to make sure that whatever number I multiplied by, so 3x was times -2, the -2 can't be in the same bracket as the 3x. And that has to do with like distributive property. If you just remember that as a rule, well, that means -2 can't go in this bracket. It must go here. And -5 can't be in the same bracket as this one, so it must go here. So if you look at the amount of written work we've done, this one tends to be a little bit faster once you get good at it. But there is a bit of mental math and remembering a process. So concise and quick once you get this fearless factoring, but it also depends on how much of the process you remember. We ended up at the exact same answer, which worked out great. I mean, we could type it in. We technically already went through some of the graphing, but we'll type in the factored form of it too. Our factored form was y was equal to x minus 2, 3x minus 5. Now, minus 5. And if you notice, they overlap. Let's talk about the x-intercepts here. One x-intercept was 2, okay? And one way we can tell x-intercepts is a lot of times when there isn't a coefficient in front of the 3, they'll tell you, hey, just use the opposite value of this. So it's, hey, opposite of 2, one of the x-intercepts must be positive 2. And that pans out here. We got a positive 2. It doesn't pan out here because we have an a value that's not 1. So what's really happening in this process is we know, and I'm going to jump back across, x-intercepts have a y value. Notice they both have the same y value as 0. So instead of typing in y as that variable, I'm going to replace it with 0. Okay, and then we're going to get is equal to x minus 2 and 3x minus 5. Now this is a very interesting scenario. What's happened here is this bracket is multiplied by this bracket. And we have a very interesting number, 0. In order to get a 0, you have to multiply by a 0. So that means one of these brackets, at least one of them, must equal 0. So we're going to come up with the potential solutions. So this is where we get two solutions, that idea of two solutions in mathematics. I'm going to set the first bracket to 0. 0 is equal to x minus 2. And I'm going to set the second bracket equal to 0 is equal to 3x minus 5. So I've kind of extended our factoring to find out x-intercepts. When I isolate for x equals 2. Hey, that checks out with what we had before. Here's a little more work. When I bring that 5 over, I get 5 is equal to 3x. And then when I isolate x, I get 5 divided by 3. And if we jump over to our calculator, 5 divided by 3 gives you that 1.6666, and lo and behold, that, they did a little rounding, that is our other x-intercept. Okay, so that's how we ended up with a scenario of not a natural number for an x-intercept.